Jeff? On my stream yesterday, I was like, man, where's Jeff? Where's my favorite viewer who only leads me down good paths on helping out questions? You keep me honest, Jeff, which I appreciate as well. But okay, let's see. First question I think comes up from a Darsh. Ooh, this has a lot of little interesting stuff in it. Let's see. It's okay. I apologize, Jeff. Our friendship is restored. It's reestablished. Let's see. Is it Darsh in the crowd? What's up, Darsh? What's up? Where's the Dookie? Let's see if he's around. This is actually a good one on exponents. My copy of the streamer calendar was broken and didn't show your stream. Only showing Zach. Well, maybe that's just Zach. Yeah. What's up, Darsh? Okay, cool. Yeah. I would like to blame it on the fire, Jeff, but not really. I was late starting because I was at UCLA helping out some professors with their first day of class. I can blame the fire because the fire did contribute to the traffic. There was more traffic for sure, but no, I'm safe for now. I mean, I will say, yeah, the fire is only probably about 4 or 5 miles from me, but I don't think it's gonna make it this far. It would have to burn through a lot more shit first. But okay, Adarsh, how do you think we start this one? This has a lot of like scary variables going on here, right? And we're supposed to simplify it somehow. The first thing I see that's like really easy to deal with is turn the bottom into 1. Yes, exactly, Shantrix. Yeah. So, little known fact: anytime you have something to the 0, like to the 0 power, that's always 1, right? 3 to the 0, that equals 1. 4 to the 0, that also equals 1. 42069 to the 0 also equals 1.
Nice.
So anything to the 0 power is 1, except 0 to the 0. 0 to the 0 is, I believe, undefined. But yeah, you can't do this. This is bad. Yes, good. So yes, because the denominator is all to the 0 power, we can change that whole thing as 1. So this is all going to go away and just become 1. Okay, nice. And because we're dividing by 1, I don't really care about this thing anymore, right? Just get rid of it. Okay, so now I'm just left with this part, which is interesting. What if x equals 0? Ooh, then we have 0 over 0. I think we're assuming I think we're assuming all the variables here are non-zero. Okay, but now that we got to here, so now I have all these things inside of this parentheses house, and they're being raised to the -2 power. What do I need to do with this? Like, if I have everything going to like a power. Oh, I'm not speaking on Discord. You're so right. Oh my god, thank you, Shantrix. Sorry, yeah. There we go. That's fixed. Okay, cool. Bingo. Yeah, what do we do here? What do we do? Also, I need what's wrong with my stream deck? Go to camera hub. Dun, dun. If only intro algebra is taught with domain restrictions. Yeah. They don't even like really they don't even really say what like a domain restriction is in algebra to start off with. But yes, we do distribute. Okay, so how do I distribute this? Like you're right. If you have a bunch of things multiplying by each other, this exponent needs to get distributed to everything, okay? And that's because they're multiplying. If, for instance, you had this, let's say x to the 3rd plus y to the 4th, all to the 2nd. Some people are tempted to take this 2 and distribute it to each one of these things, but that is wrong. You can't do that when things are just being added. In reality, what this is, when we say like to the 2nd power, this is like a carbon copy of this thing being multiplied by itself again. And in this case, you end up having to do, I don't know, that evil FOIL thing.
Surprise, motherfucker.
Which, yeah, sucks. So, difference. The difference there. If you got stuff adding and subtracting inside the parentheses and you have an exponent, you can't distribute it. That does not work. So, because things are multiplying by each other, they do distribute. So, this is actually kind of cool. I can actually kind of show how that works. Yeah. Let's say, for instance, we have... you know what's funny, Raven Violet? That sound is random. So, when I click that button, there's like 12 different sounds it can play, and it just happened to play the surprise one. I guess it works sometimes. Let's say, for instance, I had x to the third, y to the fourth, and then this was to the third. Okay. I know I'm going to distribute this to each of them, which is eventually going to become x to the ninth, y to the 12th. Because what happens when you have an exponent to an exponent is the exponents multiply with each other. So that becomes 9. 3 times 4 becomes 12. You can see this as well if we wrote this out, if we like expanded the exponent out to just be this thing multiplying itself 3 times. Because that's what exponent means. Exponent means like multiply by myself the exponent number of times. And so if I did this, right, to the cube, that's like, yeah, multiply it by itself 3 times. Now you can see that, like, these all kind of, like, group with each other, right? Yeah, I like that, Shantrix. Exponent is repeated multiplication. Correct, yeah. So all of these 3 things are multiplying by each other. Well, here's also, like, kind of the rule. I believe it's called the commutative property, which is that if you have things multiplying by each other, you can change the order, and it doesn't do anything different. So, like, 3 times 4 times 5 is the same thing as 4 times 3 times 5, which is the same thing as 5 times 3 times 4. Like, it doesn't matter the order for multiplying. And so the same thing here. When you have, like, this times this, but also times this, you can write them in whatever order you want. And I could just say, oh, this is x to the 3, x to the 3, x to the 3, times y to the 4th, y to the 4th, y to the 4th, right? This is x to the 9th. This is y to the 12th. And so you get your original answer. X to the 9th, y to the 12th. Okay? That's where this comes from. Exactly. Yeah, you're very, very right. Yeah, okay, yeah. So you're so right, Saint. Yeah, every number, but kids usually get this wrong. This is kind of the tricky part. You also need to multiply the number. Yeah, I know the number doesn't have like an exponent, and it's not a variable, but it also needs to get multiplied by the exponent. Or it also needs to have the exponent hit it, because this is like 5 to the 1, is what we would say. So when this goes through and hits everything, that's going to end up being 5 to the negative 2, x to the negative 6, y to the negative 8, z to the positive 16, because that's negative 8 times negative 2. Yeah. Now, at this point, we can start to simplify some things, because your teacher usually will not let you leave things with negative exponents. Like, it's not allowed. If you have something to a negative exponent, do we know what that does? Like, how do I rewrite something as a positive exponent if it originally had a negative exponent? One over the exponent, where x is the exponent. Yeah, exactly. Yeah. So anytime you have a negative exponent, it just means write it as a reciprocal and then make the exponent positive. So, for instance, if you have x to the negative 4, this is the same thing as 1 over x to the positive 4. And I'll show you, this works in reverse too. If you have, for instance, 1 over y to the negative 5, this is the same thing as y to the positive 5. So again, you flip the placement of it. If it's on the top, it goes on the bottom, and now the exponent is positive. If it was on the bottom, it goes on the top. And now the exponent is positive. If you have like fractions, let's say you have this. Let's say you have like 3 over, I don't know, 7. And then this is all to the negative 3, okay? So first of all, whenever you have a fraction and you have an exponent here, each one of these things gets hit by the exponent. It's the same as if these things were multiplying by each other and had an exponent, it would hit both of them. So this ends up being 3 to the negative 3, 7 to the negative 3, which means that this one goes down and then this one comes up. So this ends up becoming 7 to the positive 3 over 3 to the positive 3. The other way, like, people will kind of look at this is I'm just going to flip this thing and then make this positive. So this is the same thing as 7 over 3, all to the positive 3 power. Yeah. You have fractional exponents. Yeah. Multiply the numerator. Yeah, negative 2 times. Yeah. How do you multiply something with itself negative 2 times? Yeah. So anyways, yeah, that's where that all comes from. Okay. So once you got this, pretty easy. Just anything that's negative exponents, put it on the bottom, make the exponent positive. So instead of 5 to the negative 2, that's 1 over 5 to the 2. Instead of x to the negative 6, that's 1 over x to the 6. Instead of y to the negative 8, that's 1 over y to the 8th. And then the z to the 16th stays. Last step is to simplify. So 5 squared is 25, right? So we can just call it 25. And then times that, times that, times that. And then this is on the top. So you're left with z to the 16 over 25 x to the 6th y to the 8th, and you're done. Perfect. Yeah, so that's a fun question. There's a lot of concepts in this one which I liked. You know, you had distributing exponents, you had the negative exponent rule, and then you had the to the 0 exponent rule. Yeah, good question. Cool. All right, let's see. Shantrix, you got a nice little puzzle for me? You got a puzzle for me today? I do like the puzzles. Ooh, this is question 25 on the Putnam, right? That means this one's gonna be tricky. Yeah, I know this one's gonna be tricky now. Okay. Because isn't 25 like the last question? I think it is. Oh, it's Pascal. Putnam is harder. Oh, interesting. I don't know why I thought that. Like, I guess I know that one. Who is Putnam again? Is he like some guy? Putnam math? Is he math? Is he a math person? Oh, William Lowell Putnam. Who's this guy? That's cool. Are these all the universities that have won? MIT, Harvard. It's just always MIT and Harvard that wins. Wow. Oh, that's cool. I guess Putnam is a person. Wait, who's this guy? Was he a math guy? He was a lawyer and a banker. Man had an epic mustache, I'll tell you that, dude. It's pretty dope. Uh-huh. Oh, that's cool. Well, I guess he wasn't directly related with math, but he funded it, so that's cool. Yeah, good job, dude. I guess the Putnam contest is for college students and the Pascal is for high school. Okay, a 0 or 1 is to be placed in each of the 9 1x1 squares in a 3x3 grid, so that each row contains at least 1 0 and at least 1 1. Okay, I always have to remember which ones are the rows. These are the rows. and each column contains at least 1 0 and at least 1 1. The number of ways this can be done. Oh, wow. Okay. Yeah. At least. Whenever I see like at least 1, I feel like that's 1 minus the probability that there are none. Right? So maybe, yeah, let's think about like, yeah, maximum amount of ones. Yeah, exactly. So let's think. You need at least 3, right? In order to hit every row and every column. So like 1s and 0s. You need like 3 and 3. Well, okay. So you could have 3 here, 6 here, and then you could have 6 here and then 3 here. I think, yeah. Because, right, if this is 1, 1, 1, then you've covered every row having 1. And then this covers every column. And then it's the same thing for the zeros. Well, and then everything else is a 0. So that's 1, 2, 3, 4, 5, 6. Okay, but then we got to think about the ways that has to be placed. Oh, shit. Oh, man. What's up, Unstable Bucket? Okay. Because within this, right, I have 3 choices, I think, right? Because I could have this one here, or I could have this one here, or I could have this one here, right? Oh, you can have empty squares too? Oh my god, what? No. No.
No.
Bro, that makes this so much harder now. Let's think. Okay. Yeah, no. It says there has to be. It says a 0 of 1, a 0 or a 1 is placed in each of the squares. Yeah, so you can't have empty squares. Yeah, no empty squares. Okay, so I get the. You could have 3 1s, and then the number of ways you could do that is that 3 factorial, right? Is that the permutation thing? I think yeah, right? Because this could be 1, 2, 3. Right, 1. Well, okay, 1 second. If this is here, you could have. There's 2 ways for that, right? And then if this is here, you have 2 ways for that. Okay, and then if this is here, you have 2 ways for this. Right, okay. So there's 6. What's up, Skeeg? Yeah, you can create columns if they're, yeah, exactly. Yeah, I don't want to, yeah. I think if I don't want to repeat columns, there's only 6, right? There's only 6 unique ones. So 6 unique, right? Because then I could swap the ones with zeros. Okay, that's like the minimum case that I can do. let's add in another 1, I guess. Okay. And then it's like, where can that 1 go? You know what I think I'm going to do? I think I'm just going to find the number of unique ways I can do 1s, and then the 0s will kind of follow, I think. Right? Like, we're going to hit some halfway point where... It's kind of like when you're doing factoring. I'm trying to think like this. When you do like 1, 32, 2, 16, 4, 8, and then it starts becoming 8, 4, and then 16, 2, 32, 1. Like there's always some like halfway point where you're just hitting the mirror image of it. That's kind of how I think about it. So I think I'm just going to look at the amount of 1s, and then when I get to that halfway point, I'm just going to double it. Which yeah, exactly. And I can already see that, right? The number of ways this can be done is even. So I think let's just figure out the ways we can do it with 1s, right? Okay. So if I have, let's just say 3 1s, for instance, there are 6 unique ways to do this, okay? If I have, let's say 4 1s, okay? And actually, I don't really care about this anymore. This doesn't really matter. Because we know at a maximum, the maximum number of 1s you can have is 6. Because once I have 6 1s, that gives me the 3 0s. So actually, we just have to do this, right? We just have to find the number of unique combinations for 3, 4, 5, and 6 1s, and then double it. And that'll mirror image the 0s, I think. Or actually, no, I think that covers all of them, actually. Yeah. Because the 0s are all, they're all the same, right? 1 0 is 3 and 4. 3 and 4 covers all, you think? Oh, 3 and 4 covers all, and then I can double, I think. I think that's what you mean. Yeah, exactly. Yeah. So I could either do 3, 4, 5, 6, and we're good, or I could just do 3 and 4 and double it. Yes, exactly, Saint. Yeah. Okay, now I'm seeing it. I'm starting to see it. Okay, so we already found out 3, so now we just got to figure out 4. Okay, let's figure out 4. I'm going to hold one of these constant, right? And now let's think about where I could put that 4th one, right? So I could put the 4th one. Consider the 16 possibilities for the top left 2x2 corner. And then, okay, and then you're thinking it's just times 6 is 96. Consider the 16 possibilities for the top left 2x2 corner. Okay, I think you're thinking like the 1 0 0 0 1. Where's the times 6 coming in? Oh, just your guess. Yeah, because 96 is here. Yeah, maybe. Let's think about it this way. All right, let's say I have a 1 in the top left corner, okay? And I'm allowed, and I know I'm going to have these things playing around to get me my other combinations, but I have an additional one that I can use, right? I could either put it here, right? The 4th one, okay? And then let's see what that does for our combinations, right? So obviously this works. So I'm going to just start tallying. So maybe I can start seeing stuff, right? So we got this. Or actually, no, this doesn't work. Sorry, my bad. This works. Okay. Yeah, thank you. Yeah. Yeah, perfect. Yeah, we do have to leave one open. Yeah, okay. So, oh, this is interesting. Yeah, I can't clog any row now as well. Oh, wow. Man, this is such a it's a fun puzzle, Shantrix. Okay. This is okay. This is okay, right? This is not. Okay, cool. All right. And then for each one of these, let's see what we have. We have 1, 2, 3, right? So we got 1, 2, 3. And that's for each of these, right? So that also works for this one. Oh, actually, oh, but that's double counting this one. No. Yeah. 1, 2. And then you have 1, 2. Okay, so you only have 4. Once we place this here, I think. Yeah, none of the rows of columns are more than 2. Yeah, okay. So I see 5 here, right? So if I place this here, I can either... Let's look at the combinations. There's this. 1, 2. And then there's 3. And then 4. Okay. And that was for placing this here. I think. Yeah. Right? I think it was right. Yeah. 1. No one in the last row? Well, okay, yeah, sorry. Yeah, let me... I'm starting to forget, like, what we're... Okay, this is here. This is my fourth one I've placed. Okay. I can't do this. I can't fill any rows. I can do this, and that gives me 1 choice, 2 choice, right? Or I could do this, which only gives me, which gives me this choice, or this choice, right? You can't do the 1 in the last row? What? Why not? Oh, go back a couple. Okay. Okay. Oh, yes. Sorry. Yeah. This doesn't work. Thank you. Sorry. You can't do this. Yeah, okay. This is what we can do. This I can do, right? 1, 2, 3. Okay, there's 3 from that. Actually, you know what I'm gonna do here? I'm gonna keep them all at the top. I'm just trying to keep my head straight here. I'm gonna keep them all at the top, and we're gonna go through them. Well, but I can't do this. So this is the first step, is moving this one up. If I move this one up, I have 1. No, this doesn't work. You're right. Sorry. There's this. I only have 1 choice, right? Which is this. Okay. Let me get rid of this. Okay. Okay. So we have 1 from doing this. This is the one that works. Then I have this, which I have 3 options here, I guess, right? Right? 1, 2, 3. Okay. Now let's place this here and see what we could have done here, which is only here. So there's just 1 more, right? So that's 5. Right? Keep me honest here. Right? 1 choice here. Well, 1, 2, 3. And then, I guess 1 there. And then 1 there, and then there. Dude, this is starting to mess with my head. Oh my god, Chantrix, what? Just draw 100 boxes like that and fill them out uniquely? Christ. No. There's got to be a way to do this. I was happy I got this first. I was happy I got the 3 ones right. Got the 3 ones right. I was very happy about that. This next part is like kind of messing with me, dude. Because then this is going to change once I like place this down here. And then like it could be here and then it could be here. But maybe those are just doubles of each other? Well, I assume being in the middle. No. Yeah, I think if I figure out where this can be, like here or here, then I can multiply it by 3 for doing it here, here, or here, here, right? For this fourth one. Oh, but then I need to consider having 2 like additional ones. Oh God! Oh, this becomes a motherfucker. Okay.
Why does it matter if they're unique? It doesn't say anywhere that they have to be.
Well, I assume when they say the number of ways in which it can be done is the number amount of unique combinations.
Totality. The number's too big for just being unique.
Is it just infinity? Yeah, there's infinity ways I can do this. They're talking about how many unique ways you can do this. Man.
Well,
yeah, this is the sort of problem you would brute force in Python in real life. Correct, Saint. Yeah, 2 ones and multiply by 3 seems promising. I agree. But then I have to consider if I have another additional one. No. Actually, no. We don't have to consider 5. No, thank you. Actually, Saint, Dr. L, Dr. L, you gave me hope again. We don't have to consider 5 ones because we're just gonna double it. Yeah. No, this would be great to just do this in code, but no. Okay. I think we can get this. I'm pretty sure we can get this. Okay. 1 sec. Okay. I place this one here. If I move, let's just look if this stays in this position. How many do we got? We got 1, 2, right? There's only 2 positions for that. I'm gonna get rid of these. Okay. 2 positions this can be, right? Actually no, there's just 1 position it can be. Okay, it can only be there. Good. Okay. Now let's move this one down. And let's see what we get. That's 1. There's still only 1 position this can be.
It's 2 to the 9th power, Jesus.
Is it 2 to the 9th? Why do you think it's not 2 to the 9th, Sensation?
Because it could only be 1 or a 0.
Yeah, no, but look at the rules,
in
Sensation.
any given box, there's 9 boxes.
Yeah, but look at the rules. Is that each row contains at least one 0 and 1 1. And each column. This is the clusterfuck.
At least.
Yes. Yeah.
No.
That's
at least.
Uh-huh.
And so it still boils down to any given square having either a 1 or a 0.
Correct, but then there are rules. So for instance, Sensation, this is not allowed. Because now I have no zeros in this row. That's the issue. This is why it's a cluster.
Right.
Yeah.
Well, so the maximum value before you implement the rules is 2 to the 9th.
Correct. Yeah, exactly. Yeah. Yeah, that would be nice and easy. We would love that.
Perfect.
We'd love to just 2 to the 9th. I'd jump for fucking joy, dude. I think I got this. If this is in the first, if this one is up here in the top, you only have 1 possibility, which is this down here. If you have it here, you only have it, again, being here. If you have it here, now you get some play, right? So now, this is okay, and this is okay. So that gets you 5. Okay. Mew. What's up, Raven?
Okay.
Yes. Okay, so there's 5. Okay. Now let's do the thing where this one is going to be here. Okay. In that case, I have, again, let's force this up here to start. This doesn't work. I have I have 1 placement here, I think it can be. Well. Yeah, exactly. Yeah, that's kind of what I'm getting at. Right. When this was here, and I placed this here. Wait, when I placed this here, there's only 1 option, which was for this to be down here. That's the 1. When I look at like what I can do with this. In this case, there's only another option there. Okay, and then when I'm here, now there's this, and there's this. So that's why there's 5. Go. Now let's look at what happens. And we're going to multiply that by 3. Because, well, we're going to multiply the total by 3 because then we could do this in each of the 3 columns. Is what we're gonna do. I gotta remember, like, we're multiplying this by 3, by 2, by whatever. Yeah. Okay. If this one is, because then all we have to do is this, and then we're done. We're so close.
Wait.
Okay,
Well, I think I just figured it out right. If you put 1s in all the boxes, right, but then take out the diagonal right down the middle, and just say this diagonal, it can be any given either position, right? So
yes,
you do 2 to the 9th plus 2 to the 9th minus 2 to the 3rd. So then that should be all possible combinations.
But that's gonna be a really high number.
Minus
right?
zeros all.
2 to the 9th is like fucking 500 or something, isn't it?
2 to the 9th, 512.
Yeah. Right. Yeah. We can't have that many combinations. I think I got this. Okay. This is this. Okay, let's see what we got. I can have this. Well, actually, no, sorry. If this is here, there's 2 combinations, right? There's this or this. So that's 2. And then if this one is here, I have this, and this. Right? That's 3. Oh, I can't have an empty. Did I fuck that up already? God damn it. 1 sec. Yeah, let me cook. This is okay, right?
All the time in the world to get the English language right, and you can't even type English.
Yeah, it's all right. Let them. They're right. They're English. Yeah, whatever. It's internet speak. Yeah. Oh, I see. Oh, this doesn't exist. Okay. Thank you. You're right. Okay. This is all I can do. Right? There's only 1. Okay. There's only 1. When I'm here, now I have 1, 2, 3. Correct, right? 1, 2, 3. And now when I'm here, now there's only 1. Now there's only 1 choice. Okay. So that's another 5. Okay. Okay, cool. And that was just moving this down. So then the last thing I have to solve is for these 2 here, which I think should be the same as these 2 here. Okay, so there's just another 5. Okay. Okay, so that's 15 ways to do it with this. Then I multiply that by 3. Right? So that's 45. And then I add the 6 unique ways to do just 3 ones. So that's 51. And then I multiply by 2. Should be 102. Is the answer 102? Ooh, he's gonna go check. Wow. I need like a little like drum roll. Like is it gonna be right? Dr. L thinks it's 102. It is. Wow. Thank you, everyone in chat and everything and Discord that like helped me. You know, this was kind of a tough one. Wow. I really enjoyed this though. Man, that feels so good to get right. I'm gonna have a great day today now because of this. I don't care what the fuck happens. I don't care if my apartment burns down because of the fire like down the road from me. Because I got this question right. With y'all's help. Y'all helped me out a lot, but this was actually really cool. They did the same process, 3 by 15. Yeah, okay, cool. Nice. Cool. Yeah, thanks, Dr. L. Yeah. Counting has been so rough for me. I mean, it has been for me too, honestly. I'll admit, when Shantrix first started like submitting these questions to me, they made me very like sad.
You done messed up, Aaron!
I felt really upset about myself because yeah, I usually ignore these types of questions because I'm like, whatever, fuck it, I'll just run code and do it. But actually getting these and doing them, they become easier and easier. This is a beautiful metaphor for how life works, right? You have to do shit you don't like and you're fucking bad at a couple times before you start getting kind of good at it, and then you start enjoying it. And so, yes, thank you, Shantrix. I appreciate you submitting these, because at first, yeah, I used to always just be like, I'm gonna look like a fucking dumbass on my stream, dude. But now I'm starting to get them a little bit more, and yeah, they make me happy. And also, I kind of it speaks to the idea of everybody struggles. Everyone has problems with things, and if you guys can see me struggling, maybe it helps you to think that, oh yeah, struggling is a normal thing. Yes, yeah, thanks, Shantrix. Yeah, sorry, that was late tonight. Yeah, thanks for coming by, dude. Appreciate it. So yeah, if you do more of these, I think you start building the neural pathways for how to tackle these problems. And that's kind of what I've... Yeah, also your coin. Yeah, you get a coin, Shantrix. Yeah, my bad. Yeah, of course. He says, also, where's my coin? Yeah, I'm starting to make the clicks of what you do. It's a lot about, like, trying to simplify what are the different cases and which cases duplicate. Once I think we had figured out that, oh, I just need to figure out the number of ways to do it with 3 ones and 4 ones, and then double it because it's the mirror image for the zeros. That eliminates so much fucking work. And then once we realize that, like, oh, just doing the 3 cases is easy, now we only have to do the 4s. And now, okay, looking at the 4s, I can triple it because whatever I do in one column, I could do in the other 2. You just start narrowing down what you actually have to brute force, which is actually not that much. And maybe I could have noticed that after the... And I kind of did notice this, right? After I got the second 5, I was like, oh, they're all 5. Yeah. Cool question. Could you do it for my 4x4? God damn it. Fucking Jeff. You want to do it for a 4x4? No, I do not. I'm not that much of a masochist. Yeah, Dr. L says, easy is what we know, difficult is what we don't. That means learning can only happen if we live with difficult. Yeah. Hey, Recky Rec with all... Dude, Recky Rec with the all due respect. You love this term, all due respect. I think it was yesterday.
I'm gonna slap you in the face.
I know. Yesterday he was like, "With all due respect, can I have my gift card now?" Just like, he's like, "I'm not being pushy, but with all due respect." I like that you at least attempt to be respectful. He's like, "Yeah, I do."
But yeah, be aware. With all due respect means I can't slap you in the face, but I won't.
It's okay. Yeah, I will do a Darsh's real quick. I'm sorry. Yeah, because he did say with all due respect, and I respect that he's at least being honest about how he uses with all due respect. I read it as sarcasm. You can't read sarcasm on the internet. Okay. Based on the general formula, identify each compound as a straight chain, alkane, alkene, or alkyne. Yes. Oh, and they give you this little hint. That's fucking cute. What? I didn't know this. Okay, in general, alkanes mean they only have single bonds. Alkenes have double bonds, and alkynes have triples. Yeah. Yeah, if you're already given this hint, now it's just fucking trivial, dude. What? Let's kind of see, like, I'm going to show example. I'm not going to do these. Like, fuck this. I'm not drawing out C15H28. I watched Alkane. You mean Arcane? I need to watch that, too. But let's see, for instance, like C2H6. Okay, CC. And then they say there's six hydrogens, right? So that's 1, 2, 3, 4, 5, 6. That's cool. The rule in chemistry is that most things want 4 things attached to it. So this carbon and this carbon just wants a single attachment, such that this has 4 and this has 4. Hydrogen is the exception. Hydrogen just wants 1. This is an example of an alkane. Okay. if I wanted to make this an alkene, okay, that means this thing would now become a double bond, okay, and we would lose a hydrogen on each one. This one would go away and this one would go away. Because again, I only want carbon to bond to 4 things. It doesn't need any more hydrogens. In this case, right, 1, 2, 3, 4. Carbon's happy. In this case, 2. 1, 2, 3, 4. Carbon's happy. What is an alkada? Oh, man. Okay, cool. And if this was an alkyne, which means a triple bond, now I get to get rid of another set of hydrogens. Okay, so now this goes, because we don't need these. That's cool that there's a mathematical formula to this. Also, does an alkene mean that all the C's have to be double bonded to each other? I don't think so, right? Because if you had a bunch of these, like, that doesn't really work. Because then you would have no hydrogens. Yeah. But that's cool. Yeah, so if it's an alkyne, I think alkene means that at least one of them has a double bond. So, for instance, like, if we wanted to say C3H6, that would be like C, and we put a double bond on one of these. This becomes a single, I think. And then that's H. This just needs a single H. And then this needs 2 H's. Right? Because, look, 4 things. 4 things. 4 things. And then let's see, how many is that? 1, 2, 3, 4, 5, 6. Oh, cool. Yeah, no, this is really cool. I mean, this helps a fuck ton. Having this. Because otherwise, like, drawing this out, like, wow. Ooh, it would suck. You're pretty good at organic chemistry for a physicist? Aw, thank you, dude. Is this really orgo? I mean, I think it's just kind of basic chemistry, but... Anyways. Okay, cool. So you can just use this formula, right? So this one is very easily an alkene. Because N is the number of carbons, and H is 2N. So 5 to 10, cool. 2 to 6, that's going to be an alkane, I think, right? Oh, we already did that one. And that makes sense, because in this case, N is 2. 2 times 2 is 4. 4 plus 2 is 6. Yep. Cool. Ooh, these get tricky. 1528. So if it was 1530, that would be an alkene. But since it's 2 less, that means it's an alkyne. Yo, what's up, Zach? Good to see you, Zach. Yeah, Jess here too. Yeah, we're doing a little bit of OChem, dude. Or I think this is like basic chem. Okay, and then this one, right, is 2 more than twice. So this is an alkane. Okay, so this is actually a really cool rule here. You just look at the number of carbons there are, double it, and if it's equal to that, it's an alkene. If it's 2 more, it's an alkane. And if it's 2 less, it's an alkyne. Salt is basic chem. Dr. Gold is basic chem. I don't think there is a DR. Anyways, yeah, cool. All right, cool. Good question, Reki. That was fun. Oh, what game did you buy with the gift card I got you today? What'd you get? Tell us. You said something was on sale. I'm always just curious what you guys are playing. All right, and then we got equity. Oh, who's putting all these nice little hearts on things? Oh, thank you, Ricky. Oh, Batman Arkham Collection. Ooh, that's dope. Yeah, Arkham Asylum. Yeah, that's cool. Nice. Nope, no, doctor. You are correct. Yeah, very cool, Ricky. That's dope, dude. Yeah, you're welcome, dude. I'm glad it worked out. I'm glad you were able to make an account that it worked for. I always want you guys to get rewards that like are useful and like are enjoyable because you guys work hard, you know. Okay, let's see. Is equity around? Equity's next, and then Ace. Yeah, you're good. Do your night routine. Yeah, peace out, dude. Oh, shit. Sam says it's getting closer. Uh-oh. Let's go see what's happening. Uh-oh. Are we evacuating during the stream? Oh, man. Don't do this to me. I don't want to deal with an evacuation right now. Wow, that would suck. Sorry, let me check on the news real quick to make sure my apartment's not going to burn down. Because as I was showing people, I live very close to whatever this fire is. Yeah, so this fire is here. And I live, like, right here. Yeah, I live, like, right here. And Sam, I'm pretty sure Sam lives, like, down here. So he can already see this happening. That's not good. Okay. Oh, the Getty Museum is on fire? Oh, God.
You done messed up, Aaron!
Oh, no. Yeah, the reason why this fire is particularly bad is because we have what are called the Santa Ana winds. It was a very windy day today. The winds were like up to like 100 miles an hour, apparently. And when you have really strong winds, that causes it causes fires to get bigger because in order for combustion to happen, this is a good little chemistry lesson here. You need oxygen and a hydrocarbon in order for combustion to occur. So yeah, it's like, I don't know, like C3H whatever. Oh, right, we could do this, right? Plus O2 ends up giving you CO2 plus H2O, and then plus like some other stuff. It's usually like or whatever. This is how combustion works. You have hydrocarbons mixing with oxygen, light a match. You get carbon dioxide. This is the stuff that's bad for the climate. And you also get water. It's kind of cool. So if you have a one second, let me move this. If you have a healthy supply of oxygen from, say, I don't know, like the wind, then this causes this reaction to happen a lot faster. So that's why shit burns like brighter, hotter, whatever, when you quote unquote fan the flames. I don't know if you ever know. I don't know how many of you guys have like created fire. I like burned everything in Boy Scouts, so I'm kind of like a pyromaniac. I love fire. Fire's great. But if you blow on a fire, contrary to popular belief, I mean, if you blow on it too hard, it'll go out. But usually blowing on a fire creates more fire. Yes, Ace. Yeah, you can go next. Because I don't see equity yet. And then in addition to this, the problem is that the wind is carrying burning pieces of ash, like burning leaves, and throwing it at more stuff to catch on fire. So that's why this fire is doing a lot. Doing the most. Okay. Yeah, let's keep running through some questions before my apartment burns down. Ooh, we're doing geometric sums. These are fun. Okay, cool. Let's roll it up. All right. It says determine the sum of each. Okay, so this is cool. These are now series. But isn't your melting point? Yes, gold is. Yeah, is that the melting point of gold? 2,000 degrees Fahrenheit. Yeah, I can withstand the heat. Someone's asking me if I want to go play video games. I'm like, bro, I don't know if we're. I think we might be burning down at this point. One sec. Yeah, so series are different because series are different than, so a sequence is kind of what I think of as like a list of numbers, whereas a series is adding the list of numbers together. Okay, so we're dealing with series now. For arithmetic series, let's remember that what's the difference between an arithmetic and a geometric series. Arithmetic series are numbers that the next number in every part of the series is just an additive or subtractive, which is basically adding a negative number difference. So these are, for instance, like 3, 6, 9, 12, right? Everything's going up by 3. Geometric is where every successive number, every next number, is a multiplication of some sorts. So for instance, that could be 3, 6, 12, 24. In this case, right, everything's being multiplied by 2. In this case, everything's being added by 3. That's the difference between the two series. And they have two different formulas. I'm trying to remember the way I like this one. I think, isn't one of them like the average? It is actually. Ooh, I remember how this works. Yeah. This is cool. So this looks like kind of a really fancy formula. Do you see how they do like n over 2, 2 times a? In this case, a is always, I believe, like the first term. And n is equal to the number of terms. So, yeah, one way to do this is to do this like weird formula, which is like n over 2 times 2a plus n minus 1 times d. This looks like kind of gross to figure out. Wow, thanks. Hello, Luna. Oh, that's very cool. Yeah, advice for college? Oh, that's cool. Yeah, I can give you some advice right after this this question. I'm just helping a student with a math question. But if you want to stick around in the stream, I'd be... Yeah, that's awesome. You know, one of my sisters is a pediatrician. She just passed her board exams in Philly for, I think, pediatric genetics is what she's doing. Yeah. Yeah. So, Ace, the better way to remember this arithmetic series thing is that it's just the average of the first term and the last term times the number of terms there are. So that should be kind of like apparent here. Do you see how this is always the first term? T sub n means the last term, or like the nth term. It's just an easier way to remember it. So this is like the nth term, and you're adding them together and dividing by 2. That creates like an average, okay? And then you're multiplying that average by how many terms there are between the first and the nth. Yeah. It's really cool. I really like this way of doing it. Because I mean, one way to think about it. So let's see like what the average would be here. Let's see what the sum would be, right? This would be 3 plus 6, which is 9. 9 plus 9 is 18. 18 plus 12, which is equal to 30. Okay. Now let's do the simpler way of let's just average the first and the last one, right? So 3 plus 12, that equals 15. Divide it by 2. That gets 7.5, right? And then you say, okay, so on average, I'm adding 7.5, right? That can also be kind of be thought of like what this is. Like this is like the average number. And then how many times do we do that? Well, there were 4 different numbers. N was equal to 4. So this times 4, well, 7.5 times 4 does equal 30. So because an arithmetic sequence is always adding the same amount between the terms, there's always kind of like a middle point that balances it, right? Like this is the lowest, this is the highest, and then this right here is just right. And adding up that like just right number all the times here balances out all the times that it would be lower, and then you end up getting what the sum of the actual thing is. So yeah, so this is a really easy one to do. For instance, in this one, this is -6. Oh, wow, this is all going to -39. Okay. So that's negative 6 minus 139 all over 2. So that's negative 145 over 2. Cool. And then we have to know how many terms there are in between here and here, right? And what we learned, I think, was, right, that like t sub n is equal to a, I think it's a plus n minus 1 times d. For how much longer will you be streaming? Probably another 30 minutes, 15, 30 minutes. I am going to probably end the stream a little bit early just to like make sure my apartment doesn't burn down. Is anybody else streaming today? Sorry. I mean, I might leave it longer if there are more questions. But I
with all due respect,
with all due respect, can you please stream for longer?
I think you should go to make sure the neighbor's not on fire.
Yeah. Okay. Well, yeah. No one else is streaming today. If someone else was streaming, I might hold out. But I'll stay at least to also answer Hello Luna's question. Anyways.
On the stick ready.
Yeah. Why burn down? Yeah. Meme Machine. There's apparently like a really big fire happening down the street from me. That's on the news. It wasn't you. Was it you? Sensation. One of my students who also lives in like next door to me was telling me like, hey, Dr. Gold, the fire is getting closer. And I was like, oh, that doesn't look good. LA is on fire right now. I'm like, uh-oh, that's not good. Anyways, okay. All right. So, yeah. So in order to do this one, we need to figure out how many terms, like what this term is. So I know that negative 139 is equal to the first term, negative 6, plus, we're going to solve for n minus 1, and then the difference. Now the difference between these terms, these successive terms, is negative 7, right? Because negative 6 is going down to negative 13. So that's negative 7. Okay. Now all that's left to do is to solve for n here, which is not bad, right? Add 6, that's going to be negative 133. Divide that by negative 7. What is that? Negative 7, that's 19. Okay, 19 equals n minus 1. So then n is equal to 20. Yeah. So now, I just take this answer, multiply by 20, right? Because this is the average value of every term in the series. And there are 20 terms from negative 6 to negative 139. And so that's going to get me negative 1450, right? Because the 2's will cancel. This is a 10. Add a 0. Yeah, cool. Negative 1450. Nice. That's actually that's a pretty easy one to do. Where things get a little bit harder are doing geometric series, because this equation, I don't know, I don't find it very intuitive. This one makes sense to me. You're just averaging what the value is, and then you're just multiplying by how many terms there are. This one, okay, so let's look here. Again, you just figure out what the first value is. So first value is 245. R, which is called the common ratio, that's how much this thing is multiplying by as it moves down the terms, okay? And 245 is going to 24.5, which is going to 2.45. You should start noticing that this decimal, right? This decimal right here is just moving to the left and moving to the left. And when the decimal is like moving to the left like that, that tells me that it's just dividing by 10. So dividing by 10 is the same thing as multiplying by 1/10. So that's where the ratio comes in. Okay, cool. Last thing we need to know is n, which is like how many terms there are between this and this. And I could use the formula, which I think is, right, t sub n is equal to a r to the n minus 1. I could also kind of like just count this at this point. Like, let's just see, right? This is obviously first term, second term, third term. how many more things do we have to do? So 0.245 would be the fourth term. And then we're adding zeros. So fifth term, sixth term, seventh term. This is the seventh term. All right. Good. So that tells me n is equal to 7. And now I just have to do some math, which I do need a calculator for this. I don't think I can do this in my head. Yeah. Okay. So let's pull up the calculator. So A here is going to be 245. And then we're going to say R, which is 1/10, which is 0.1. To the n, to the 7th. Minus 1. Divided by 0.1 minus 1. Ooh, this is going to be negative. Oh, it has to be negative, right? Because it's a sum of negative number. Wait, is it supposed to be negative? Oh, yeah, because, okay. Cool. And that gets me 272.222195. Wow. That's cool. What a weirdo answer. Yeah. Yeah. Okay, cool. Does that make sense, Ace? How that one works? Again, a lot of again, this one isn't as intuitive. I wish it was. This one I feel like is really cool and intuitive. Yeah, okay, cool. Nice. Good job, dude.
Well done! Well done!
Okay, Luna, what's up? Luna, what do you wanna ask some questions about college? Is Luna still here? Hello, Luna. Hello, Luna. Yeah. I was in a college classroom today. I was in 2 college classrooms, helping some professors set up some software to teach and do like interactive learning stuff. They're like, quizzes. Dun, 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 dun. We should have a Kahoot day? I'm down. Zach, you know I love games, dude. I would love to play some games. That's the quizzes, right? The Kahoot quizzes. I did these actually once. I think I made my own Kahoot quiz, or I had the students pick one. Zach Sensei, yeah. Yeah. You don't have your black belt yet? Ooh. Let's also see if Bob Ross is around. I think Bob had a question he wanted to go over. PhD is a black belt. Yeah, you're basically a sensei now, dude. Yeah. Yeah, Zach, you are. Dun, 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 bum, 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 bum. First, I need to know more about alkenes. Yeah, I guess it is technically OChem. It's very basic OChem though, right? It's just hydrocarbons. My friend says, "Are you tutoring tonight?" I said, "I might be. Looks like I might be packing." Alright, I'll ping Luna one more time. Let us know, Luna. So ask about college. Okay. Let me get an update on like what's happening with this fire. Does this thing like update? Oh, okay. I want to know what the lines mean. You're right. I think they do mean smoke. Here, let's look at the wildfire alerts. Oh no. Oh, smoke density is based on the apparent thickness of the smoke in satellite imagery. Wow, so Google is like live looking at this? That's pretty cool. I don't know where's the best place to get like live updates on this. Oh wow. Oh wow. Somebody's house. Oh dude, yeah, this is sick. Dude, look at this. Well, I mean not the house is burning. I was gonna say that the helicopter's coming in. Yeah, what's really like messing this up are the winds. You can see how crazy the winds are right now in Los Angeles. Yeah, and I wonder how it started too. I think honestly probably because I know this area. This area has like a lot of telephone poles. They don't have a lot of electricity under the ground. So the wind probably knocked one of these telephone poles off, or one of these, sorry, electricity telephone pole things, and power line. Oh wow, these people are like trying to save this person's house, and it's just like, nah, dog. Yeah, and then these are cool. These are the tankers. So these things just like dump fire retardant. Yeah, but like, look at this.
It's just so sad. And I feel for everyone that's lost property and fires. I've never been this close to it.
Wow.
So it seemed to me,
This is apparently down the street. Oh, I know this. I surf here. This is Sunset Point.
whatever I lose, and there's nothing I can do.
Yeah, this is Sunset Point. Wow. Oh man. Yeah, the area they're talking about, which is, yeah, that comes from literally right here. Yeah. Yeah. No. Sorry. Sunset Point is right here. Yeah, this is Sunset Point. I surf here sometimes. And yeah, okay, wow. Oh, I know exactly where this is. This is right next to Will Rogers. Yeah. Yeah, Will Rogers is here. Yeah, unfortunately, there's a lot of, like, forest in this area to burn. A lot of, like, really dead trees. Someone said, do you think they'll evacuate Santa Monica? I hope they don't. That's a mess. Like, there's a lot of people here. This is like, yeah, there's people, but it's mainly really big mansions and rich people, you know. It's not as dense. This right here, kind of like where I live and everything, this is insane. There's way too many people that live in this area. That would be bad if the fire gets that far south. At least the smoke is blowing out to the sea. Yeah, at least, yeah, it's not. That is the nice thing about where I live, is that the smoke doesn't really hang as much because the ocean will just, the breeze will just take it out to the ocean eventually at some point. Okay, cool. If we don't have any more questions today, I might end the stream a little early. I know we started late because, again, there was a lot going on today, and I just want to maybe stay up to date with like what's happening outside my apartment right now. So I love you guys. But with that being said, let's close out the stream. All right. Thank you everyone for coming out to Office Hours Actual Education today. I had a fun time working through math questions with you guys. Our next stream, provided that Santa Monica doesn't burn down will be same time tomorrow. That's going to be 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. I will stay safe. Thanks, guys. Yeah. No, you know, worst comes to worst, dude. I'm just getting my surfboard and I'm going out to the ocean. Fire can't catch me there. Like, can't catch me while I'm catching those waves, dude. Yeah, like, it's fine. Yeah. But, yeah, it would suck to lose my stuff. It would suck to lose this streaming setup because there's a lot that goes into this. But anyways, yes, thank you. Thanks, Zach. You're good. Make sure to go follow all our awesome, amazing math streamer friends. There's their Twitches. And then here is the calendar for when the next stream is. Okay. So that being said, let's go raid somebody. Let's go send our viewers over to another friend who's streaming. We have lots of people these days. Lots of fun streamers. Let's go raid somebody. Dentistry school speed run? That sounds kind of cool. Someone's doing this. Yeah, wait, I was actually kind of curious about that dentistry school speedrun person. Who is that? Yeah, dude. Yeah, what? Yes, it was on my suggested, I think. Yeah, look at this. I don't know. Do we trust this? Do we trust this, Zach? Dentistry school speedrun. I'm an engineer. I mean, but the picture says I love hot dads. So I'm a little no. God damn it. Right, let's I just want to click real quick. I just want to see what she's doing. Like, I don't know if intended for certain audiences. Yeah, this might be my problem here. Equity is streaming? Where's Equity? Or Equity is in the stream. Yeah, I did see Equity, but I asked for him. They're trying to steal our viewers. Yeah, dude, look at this. Like, this is why I get upset. Like, all the suggestion things for me are just like thirst traps, except for I guess this alien guy. You know, whatever. Okay, who am I following? Let's go say hi to like what? Tinker's falling asleep. Science is I guess loading because he hasn't been up very long. Paleontology I think has been streaming for too long. Wait, Palisades High School is gone? Like it burned down? No fucking way, dude. Whoa. Sorry, I gotta say that real quick. Holy shit, what? Yeah, he's talking about, so here's Pacific Palisades. And let's look. I used to teach a lot of kids from Pali. Oh, yeah, that shit's fucked. Cause that's literally, yeah, that's right here. Yeah, oh man, oh that sucks. Uh-oh. Yeah, okay. Yeah, Sam lives like 5 minutes down the street from me, so he's been updating me on like what's going on with this wildfire. But this is a really big high school. I've tutored a lot of kids from this high school, but according to Sam, this high school is now burning, so okay. Yeah, surely it doesn't get much further, right? Yeah, dude, what happens? These kids just started school, and now their school is gone? It's a big school. Yeah, but there's not that many other high schools, right? There's Samo High down here. Maybe Malibu High? Is there a Malibu High School? I gotta go way up here, I guess. Oh, man. Okay. Yeah. Stuff is messed up these days. Let me see. What's Science doing? Is he doing stuff? Yeah? Okay, cool. Here, we're gonna go raid. Let's go raid Science. Go say hi to him. He's a cool guy. I remember Smash Middle School had a black mold problem and they had to split all the kids and they tore the whole school down. Oh, wow. Or you mean Samo, not Smash. Yeah. Okay. Cool. All right. Yeah, stay safe. Have a wonderful rest of your Tuesday. And we'll see you on Wednesday. All right, peace out, guys.
Using molecular biology, and we do science content here on Twitch every day of the week. Microscopy, art, sci-fi, science news of the week, deep dives into scientific topics, game, works, 3D printing, IRL stream, model building, and more. Double raid, double rainbow, Raiders!
Science stream, but we ain't bugging.